group real quick as well. I'm sure they don't care. It is cold. It is beyond cold today.
Yeah, it's crazy.
Like I went to go
It's
take out the.
frightening.
I can't believe like the lake over by me is like you can drive a car on it. That's how cold it is. All right, what do we
You
do?
tried it?
Starting stream. Reply all. Hey guys. Hey guys. All right. Let's see. We got Discord.
Yo,
I'm in the voice channel for Discord, so I'm available in the voice channel for Discord. Alright, so we are going to be building 11 projects via functions today. So Visual Studio Code open in Python. Whatever you use for your Python terminal, I use PowerShell. Make sure you're in the directory where you save all your Python files. You can see all my Python files are here, so I can run a file. 1.py. Lesson 1.py. Yeah, there's no lesson 1 because it's underscore 1, and it runs the program.
you want to share your screen or?
Huh? Oh yeah, I should probably share screen.
Yeah.
I'm like talking and you don't see anything. All right. Share screen.
Same picture from what's this? The second week of
Yeah,
the
dude.
cycle, or?
Yeah, I have always kept that as my Google one. Always remember. Cycle 35. Are you able to see the screen?
Yeah.
All right, coolio.
We laugh.
We are. All right. So let us begin. Let us begin. 11 projects. All right. Get all
Wait,
settled. All right. What is all this? Did I do all this already? Let's see. Nope.
where's the Discord?
Hmm?
I'm
I'm in
trying to find the Discord, your link to the Discord.
uh hidden copy. I will send it to you.
Awesome.
In the video, I'll just edit out this whole for like first part. Yeah. If anybody wants to join us, they can jump in there. All right. So the code challenge, Python functions. We have to write a function named average that has two parameters, number 1 and number 2. The number should return the average. Cool. So this shouldn't be too bad, right? So this is an easy one. Remember how many parts does a function have in Python?
3.
It's 4.
It's
Yes,
4
it's 4. You initialize it with def. You type in
because
the
of the
name.
colon, right?
Huh?
The colon at the end.
Yeah, the colon. Colon counts.
Got it.
It's gonna take a num1 and a num2, and then the function should return the average of the two numbers. So we know that the average, and I'm just gonna type in result, is equal to, remember, please excuse my dear Aunt Sally. Put it in parentheses first. Divided by 2. And this is so bad though, because really, it's just an average of two numbers. It's not really like the average. Like what we should do is, because like in reality, right? Num1 could be a list of numbers. Like I could put an array of like 15 numbers in here, and then an array of 15 numbers here, and then find the average between each position in the array. So what it should really be is, in the future we need to figure out a way to count how many parameters were put in. I guess right now we only have 2 parameters, so we can divide it by 2, right? And then we can return result, right? And then we can test. These are our unit tests that they provided us with. Let's run this. 50.5. Yeah, so the unit test passed. And then there's a unit test here. Should return 0. And it returns 0. So that wasn't bad. But my only concern is that what if we added another parameter here? That wouldn't be the average, right? You get what I'm saying? You feel me, Kevin?
I got you.
So,
Right.
off the top of your head, can you think of any way we could sneakily do this better? I mean, technically, like, okay, technically we could say, no, it's really the average of two numbers, and it's not average. You know what I mean?
Hmm.
It's really just an average of two numbers. It's not the average, because what if three numbers? You know what I mean?
You say what if three numbers what?
So we have two parameters here, right? But what if we had a third
Right.
parameter? We can't divide it by 2. That doesn't give us the actual average. So this function is not the average, right? It's the average of two numbers. Because the average would count the number of parameters, and then this would be, the divisor would be that amount of numbers. So for example, if we had another parameter called num3,
Mm-hmm.
this function wouldn't work, right? Because there's three parameters. But what we'll learn later on is that num1, number 1, doesn't just have to be a number. I can define num1 as a list of numbers, right? We'll get into that later. For now, this sort of, I mean, this sort of, this satisfies our requirements. So I'm going to copy this. I'm going to put it into our Visual Studio Code with
So
the
as
unit
of now,
Go ahead.
so as of now, you're saying because the parameters don't actually have values, is really hard to determine what the average is.
No, what I'm
Or
saying is of two numbers.py. So for people watching, I'm creating a file called average of two numbers.py, and this will be our program. And I'm pasting in our work and I'm saving it. What I'm saying is, right, so this formula here assumes we'll only ever have two numbers. So technically the name of this function, define average, is not correct. It's find the average. So this should be average of two numbers, right?
right.
Because if there's a list of numbers inside of here, and then we were to do something like, sum, like num1, and num1 was a list of numbers, and then we would sum num2, right? And then we would divide by some num, or by length of num1. So if number 1 was a list of numbers, right? So num1 was equal to 1, 5, 67,
Right.
and 3. The length of this would be 4, right? And then what you could do is you could write a method that says sum everything that's in number 1, result is equal to, and then it would add up all these numbers, which would be 76, right? And then you could take that result and divide, so you could say result is equal to the result divided by the length of num1. And the length of num1 here is 4, so you would get the average. The actual average would equal to the result, which is the sum of the list of numbers, divided by the length, which happens to be 4. But if somebody comes back here and they changes this and they add a bunch of numbers, it doesn't matter because the formula still holds true. Whereas if in the average we just said that there was only 4 numbers here, so we're going to divide this by 4. If num1 changes and we add a whole bunch of numbers, then this formula is now invalid. That's the point I was trying to get across. So that's why I was confused when they were like, "Hey, find the average." When in reality, that's not. It's the average of 2 numbers. Okay, so that's our the first one we did tonight. Go ahead and save this file as average of 2numbers.py in Visual Studio Code, and then create a new file. And then let's go back here to this 10th power. You want to take this one? Tell me what to type, or do you want to share
Actually,
your
10 power.
yeah? Or do you want to
What,
share your
what?
screen? You want to share your screen with me, and then I'll I'll post it or whatever. I don't know. Or you can tell me what to write.
Yeah, let me see. Let me figure this out. All right. Write your 10th power. Okay. So it has one parameter named num. All right. So we got a function named 10th power that has one parameter num. The function should return num raised to the 10th power.
So just tell me what to write.
So you got your function name, 10th power, and then in the parameters you have num. The function should return num raised to the 10th power. So next line you're gonna have
Well,
what?
we are missing one of the 4 pieces.
Oh, the colon.
I got it. All right, good.
The function should return num raised to 10th power. Oh, so return is it return num? Now, so we got to raise it to the 10th power. That's the thing.
So
Is
what?
there you gotta add in a math function or?
No. What is the 10th power? What is the second power, the third power, the fourth power, the fifth power, the sixth power, the seventh power, the eighth power? What's the mathematical term for that? Anytime you raise something to the power, it's the same as 2 to the second power is 2
Squared
squared.
and cubed and
Right. And what are those little
right.
numbers called?
The exponent.
Ah. So how do we do exponents in Python?
How do you do exponents in Python? Didn't we just do that?
We did.
Oh man.
That's why we're reviewing.
Oh
It's
man.
that weird thing. It is. So I'll give you a hint. It's a double multiplier. Remember? It was the times.
Right.
In other languages, it's like the caret. It'd be like that or something. But in Python, it's. I don't know if this works or not. Let's open this unit test, and this should give us back 1, which it does, and then this unit test should give us back. Should give us back 0. And it does. And then this unit test gives us back 1024. So all these unit tests passed. So yes, and actually, to be honest, like this is probably a better way to do it than what I did. If we look at the previous function here, I stored everything into this result. I really like, I could have just done return that. Let's double check that and test it. Yeah, so less code is better, right? So in this case, I probably should have done that as well. Okay, cool. So we're gonna copy all this code and really just copy the function. You don't need the unit test. It's more important to copy the def 10th power num return num. I'm gonna save this into a file called 10th power. on Visual Studio Code. Paste it here. I'm going to save it. Control S. And we're going to save it as 10th, the word 10th underscore power.py. I'm going to save it. And then I'm going to test it. So for when I test it on PowerShell. You can use your Visual Studio Code terminal.
So what?
And there it is. 10th power, right? The file. You see it?
Yo.
Yo, what's up? We should call John. I totally forgot. Let me see if he's around. Hey, all the unit tests are inside of this file. So this is the expected result. So this is important because there is a piece of software called PyTest, which we'll get into later on in like week 14 or something. And it will just look and run all these tests for you to tell you that your functions are correct and haven't changed. All right. So good job on this one, man. Bond. Here, I'm gonna send out a ping to John. John Old Pen. Yo, you around? All right. Okay, so let's see what it says. So write a function named introduction that has two parameters, first name and last name, easy peasy. The function should return last name followed by a comma, a space, first name, another space, and finally a last name. Function should return the last name followed by a comma, followed by a space, first name, another space. Okay, whatever. Weird. Okay.
Right, the spaces is just like it kind of throws you off a little bit. When they try
Yeah,
to.
like the wording of it. So it's gonna take two, right? It's gonna take first name. It's gonna take last name. Those are parameters with a colon. Hey man, let me tell you, on that C++, I missed so many semicolons. Dude, it was getting annoying. Like, it got to the point where like I would finish my code, and then I would literally go back over every line and look for the semicolons. But if you have like Visual Studio, it will just tell you. Visual Studio will be like, yo, you need a semicolon here. All right. So what is this
That,
doing? So it
that's how it
says,
says it.
yeah,
Okay.
the function should return the last name, return last name, okay, followed by a comma. So the comma needs to be a string, okay. It
Plural.
says followed by a space. So after the comma, we're going to put a space. The first name, another space, which we have to add the space in as an empty string here. And finally, last name. Okay. So what do you think? Does this look like I've met the requirements?
Yep. See.
I'm going to... So I'm going to use the unit tests here that they give us. You know, run it. Bond. James Bond. That looks good. And Maya Angelou. Angelou, Maya Angelou. Ba-bam!
Bond. James Bond.
Right? That one wasn't that bad. I got an easy one. Alright. I'm going to copy this. And...
That's the next one.
Yeah, you get the next one. File, new file, file, save as. And this will be called bond james.py. And we'll just paste it in here with the unit test. We're going to save this, create a new file for the next one. Yeah. Alright, let's see what the next one is. Alright, square root. Yeah. Dude, we wrote this one before. Like, we wrote this one, an honest to God real, like full on from nothing square root. Remember that?
Was that Tuesday?
No, dude. We wrote this a while ago. This was like when we first like dabbled in Python. Let me find it. It's somewhere on GitHub, and I don't know where. I have to start cutting out some of these repositories because there's way too many of them, dude. Like week 1, what is this? What is this? Oh, it's HTML. That's not good. Pester, PowerShell modules, Angular, Node.js, simple functions. Oh, I'm sure there's a Python one here somewhere. I feel dumb now. It's got to be somewhere, right? Let me check. Oh, you know what? Is it on this computer? Let's see. Let's go to OneDrive, Documents, Dev, Python, Factorial. I remember doing factorials, coin calculator. When did we do this? It might have been in C++. I don't know. Do I have a production folder in my documents? Python scripts? Nothing. No. Do I have any Python files in here? No. Oh well. Alright. So this is all you, man.
Awesome. All right. Write a function named square root that has one parameter named num. Okay. All right. So you got your the function name def square root with the parameter, and inside that parameter we have num, and after the closing parentheses we have a colon. Next line, and then you want to return to return the square root. You want to return num. Let's do how you do the square root. Is the exponent, so you want to do about the exponent 2, right? Then let me see. Make sure.
Use exponent times to return the square root. Is it this? Did they mean it like that? I don't know, dude.
Like divide it by 2?
I wonder if it's like nothing. Like if we just do that.
What?
I don't know. Here, let's test it. So this should give us back 4 if it's right. Nope. Cool. So that's not it. It says use exponents times to return the square root of num.
So num.
Is it? I honestly don't know. Oh, I hit F11. Alright. I'm gonna try to put it like, this is silly, but parentheses like that? No.
No, it's got to be a value, a number.
Write a function named square underscore root that has one parameter named num. Use exponents to return the square root of num. Oh, you know what? Is it one of those things where it's like a negative number? Like that or something? Nope. Let's see. Nope. Maybe it is. I don't know, man. Let's talk it out. What are you thinking?
Yeah, I'm trying to figure it out on my calculator. Like, how we do square root using exponent?
I'm not sure. I don't think we went over that. I know that.
Because it's the number. Any number square rooted. Let me see. The square root of 100 is 10. But 10 times.
Let's see, be on Twitch. Just saying anything. Anybody on Twitch now?
That's crazy.
I don't know.
Y'all know, man. Try 2. I don't know.
No, because that's just 256. Oh, you know what? I bet you it's half. Yep. I bet you it's half. That makes sense. So it is the squared root, right? The squared root is 2 of something, right?
Right.
So don't think of it like a squared. I'm sorry, a square is 2 of the same number. So the root would be 1/2 of those 2 numbers. Does
That
that
makes
make sense?
sense.
That probably makes no sense. Hold on. Let me
No, it
fix
makes
my
sense.
headphones. Fix my headphones real quick. Oh man, I should have paid attention more in algebra. I really should have. I'm sure there's somebody out there right now who's watching this going, "It's 1/2," just screaming at the screen. You guys are dumb. So a cube root would be a third, or 0.3 repeating, right?
Charging battery.
Ah, God, that makes, you know what? This is, first of all, this is why everybody needs to learn programming, because imagine doing square roots by hand, right? So take a number and raise it to the 1/2 power, and then try to do that by hand, versus just typing this into a computer. You know what I mean?
Right.
10 times easier. Let's run this. And these unit tests pass. I'm going to save this. And, oh man. Oh, what a joke. All right. I'm going to paste this in here. Save this as square root.py. Create a new file. All right. We are chugging along. Next one's mine. Create a function called tip that has 2 parameters named total and percentage. The function should return the amount you should be given, total percentage you want to tip. Okay, so make sure, okay, so DEF, I'm going to create a tip. It's going to have two parameters, total and percentage. And it should return the amount you should have given the total. So so total times percentage, right? Is how much you should tip, I think. Okay, so then let's do the unit test here. And run these, and 0 and 2.5 should come out. Oh, interesting. So obviously, oh, you know what? Percentage. This is wrong. Tell me why this is wrong. Percentage is going to take in a number, right? But it's not going to
Percentage
take
of
it in
what?
as a decimal. We have to convert this into a decimal.
Right. You got the percentage of what though? It's like
Yeah. Well, so for example, 25% is not 25. 25%. Okay. Let's get rid of this whole line. See? 20
up
This is
to.
why unit testing is important. So 25% is the total times whatever the percent number is divided by 100. Right? Because 25, is it 25 divided by 100 or 100 divided by 25? Well, let's run the function, see what happens. Yeah, it's divided by 100. To turn a number into an actual percentage number, you have to divide it by 100. Right? The number
Yeah.
coming in is 25. It's not 25%. It's the number 25. So if you want to tip 25%, you put in the number 25. This little formula here converts it into 25% by taking 25 and dividing it by 100 and then multiplying it by the total. You get that?
That's simple.
Yeah, well, I got it wrong the first time, so ah, not simple for me. Let's save this as tip calculator. Tip calculator.
You want to save each challenge?
Huh? Yeah, I'm saving each one. We'll put them up on GitHub for other people to look at. In case people fall behind, they have functions they can reference. We're blazing through this, dude. We're on number 7. All right, this is you. It's all you.
All right, we're going to create a function called win percentage that takes two parameters named wins and losses. The function should return out the total percentage of games won by a team based on these two numbers. Okay, so let's write the function win percentage, two parameters, win and losses.
All right, so
We want the total, so automatically I'm thinking like we're gonna add. You see the total. The function should return out the percentage, the total percentage of games won by a team based on these two numbers.
mhm.
The
tell me
total
tell
percentage
me
of
what to
won.
type.
Hmm. Would it be the average then? Like the average of? No.
No, it'd be the percent of all the games you've played. How many have you won? What percentage of the total games have you won? Did you win 60% of your games? Did you win 80% of your games? Did you win? I don't know. You feel me?
Hmm. Okay, so we're gonna do return of the total percentage.
Okay, so we're gonna return.
Now,
Yep.
return what? Win percentage. Um, how would we do that though?
So,
The win percentage of
well,
wins
we know we
because
need to get a total, right? So we know we have wins and we have losses. So wins and losses are both part of games. So we have to find out how many wins we had out of how many games we had. So how do we find out how many games we had?
you got to add up wins and losses.
Okay.
That's what I was thinking. Like you need the total of wins and losses.
Okay, so after we have the total wins and losses, right? Then what do? How do we find the percent that we've won?
Divide that by the wins.
I think it's wins divided by wins plus losses, right? Or no?
Yeah, divided by
Or
wins.
is it? Or is it the other way around?
The other way around.
It's the other way around. Okay. Let's do it the other way around. Divided by wins. So total games divided by wins. So we can do the first unit test, and the first unit test failed. It should be 50, right? So we know that this formula is incorrect. Let's try to do it the other way around. Wins divided by losses may still be wrong. Nope, that's still wrong. Yeah.
So yeah.
So wins plus losses is equal to total games played. And of those total games played, we need to find the uh, what percentage of those games were wins, right? So we so if you have a test, this is how I think about it, right? So when I get stuck on something, if I have a quiz, right, and that quiz had 8 questions, and I got 7 of the questions correct, how do I find out what percentage I got on that quiz, right? So I would
You would
take 7 divided by 8, and that would give me 87 times 100. That gives me my percent, which is 87.5. So we were correct doing this. Okay, so that part's correct. What are we missing though?
multiply by 100.
Multiply by 100. Now I think we have to put parentheses here.
It's 5 and 5. 1% is 5 and 5. So 5 and 5.
So
10. 5 and 5. Yeah, you're supposed to get 50. That's it. Because
yeah,
5 and 5
it
is
gives us
10.
yeah, it gives
5
us
divided by 10.
50.0, and it doesn't give us 50 though. I wonder why. Is it because we're divided? I mean, technically, can't you take wins times a? I wonder if you take No, it automatically converts it, right? I wonder if you take. This is gonna sound dumb, but what if you? Is it the same if you took wins times 100? I don't know. Like I really don't know
So
this.
it's I think it's 50.0 because you have well you had the
Divided.
wins yeah because it's five so 5 and 5 is 10 5 plus 5 is 10 you
Mhm.
had wins in front of that so it's divided 5 divided by 10.
Yeah, well, we do have to take this
Right.
number divided by this number. I mean, and this is kind of confusing. If you take the wins, I mean, I don't know. How do you want to do it? What's the easiest way to do it? Let me delete all of this and then let's tell me what to type.
So wins and losses win percentage. I just had a brain fart. So wins and losses. Let's add that wins plus losses. Wins and losses 5 and 5. That's 10
Mhm.
times no.
I mean, technically, so
Oh,
that's what I was getting at, right? Technically, yeah, you could times it by the inverse of 100 divided by wins, right? Let's see, let's run that. No, you cannot. I lied. Oh, you know why? Because I think we have to do that. Because I think the multiply happens before the divides. Nope, I'm dumb. Okay, never mind. Tell me what to type.
oh man, I think we're making it harder than it should be.
I think so too. I think we had it. I think it was like wins divided by this, and then all this times 100, and that gave us our 50. Because remember, Python automatically converts this, but if we wrap all of this, I hate that it adds those parentheses in. If we wrap this all in an int and run it, it gives us 50. So we can kind of cheat that way, right? So anytime we divide, these numbers get converted into the float. Anytime there's a division symbol, it automatically converts both sides of the division, everything on the left and everything on the right, into a decimal first. Then it does the division, and then we can return it back into um, an integer using that. Remember how we did the str on numbers? I wonder I wonder if we no, I don't think we would. We can try str. Like if we did this, no, it just turns it into a string that says 5. But I know we can do int and that returns 50. And let me run this. And that returns 100. So we never get a fraction or we never get a decimal. But really, like, you really don't want that though. What you really want is you really want that decimal number, to be honest. Because what if your win percentage is 66.5, right? You don't want it to say 66. It's not accurate,
Hmm.
in my opinion. I don't know. And really, like, what you really should do is you should return this, right, as a string plus percent, right? You should really do that, and it returns 50%, 100%. I'm just saying. I'm just saying. Those aren't the requirements, I don't think, based on these unit tests. But if I were a bet man, I mean, like, if I was given this as a project to do, I would return it with the percentage symbols, but who knows? I'm going to copy these and save this win percentage as the next project. File new, which is control N, control save, win percentage dot py, and then paste. Yeah. Okay. So I think what I'm gonna do is inside of the folder for like now we're getting like a ton of Python files. So we're getting so many of these. So inside of here, I'm just gonna create a folder. I'm gonna call it session1. And then inside of session1, I'm going to take all the files that we created. I'm going to sort this by date. So I know that everything that I just did would be at the top of the thing. And I grab all these, put them all into session1. And this is everything we've done so far. 1, 2, 3, 4, 5, 6. Aren't we on 7? Let's see. 7. Let's see. Nope. There's an introduction, so that doesn't count. Cool. Let's see. Delete. 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 And Control N for new file. And then I'm going to go to the next lesson. Once these unit tests pass. First three multiples. Write the function named first three multiples that has one parameter named num. The function should print the first three multiples of num, and then it should return the third multiple. For example, first three multiples 7 should print 7, 14, 21 on 3 different lines, and then return 21. Jeez Louise. Okay. So we know we need to give it the initializer, def. We know that we need to give it a name, and we know we need to give it a parameter of num, and we know we got to give it a colon. Okay, so it should print out the first three multiples of num, and then it should return the third multiple. So when it says print, it should literally print out the first three multiples, which would be num, obviously times 1, num times 2, and num times 3. I don't know if there's a better way to do this. I'm going to uncomment this first unit test and just make sure that I get out, 10, 20, 30. Oh, it wants it on 3 different lines.
I want to return the third multiple.
Yeah, but it says to print. It says should print the first 3 multiples, and they should be printed on different lines. Ugh. So let's just do this like silly and then figure out a better way to do it. So I'm gonna do this and that, and then I'm gonna run the unit test, and I get the first 3 multiples of num, 20, 10, 20, 30, and then it should print out. It should return num times 3, right? Should be the return statement. This function 3 multiple, then it should return the third multiple. Num times 3, which I don't think it does it? It definitely prints out, but it doesn't return. Prints out. Shouldn't it be like 30, 30? Here, let's see.
It should.
It should be 0, 0, 0, and 0. Control Z. Run. It does? No, it only prints out 3 numbers. Okay, so let's figure out. There's gotta be a better way to do it than this, right? The first 3 multiples of 7, 7, 14, and 21. We know the multiples are of the first 3 multiples of anything are the number divided by 1. I almost feel like you could say like, I don't know, like multiplier is equal to 1, and that, no, that's dumb. I was gonna say you could take num times multiplier plus whatever the previous num was, but that's a loop. We haven't learned loops yet. I feel like this last statement isn't returning, right? Let me let's do this and let's run this. And it's not returning anything. Is it return? Did I miss something? Num times 3? Run. Huh? Okay. Oh, because I have print still turned on.
This still would have had 2 lines though, right?
Yeah. Right here, it should return. No, I'm going to refresh my page. I feel like there's something going on with Codecademy. Return num times 3. You know what? Let me just return the number 1. Run. Ah, it's not doing that. First 3 multiples. First 3 multiples num. Let's run this in the Visual Studio. Let's do this. Let's save this as first 3 multiples. And actually, let's go inside this folder. Multiples.py. And then let's go here. And let's go to ls. And let's change directory to go inside of the session 1 folder. And then we should try to run win percentage. Yeah. Win percentage.py. I don't know. I mean, technically, you know what we could do? Okay, to get around, I think all of this, what we could do is we could say, like, we could do a variable again. Result is equal to num times 3, right? And then we could return result. Let's see if that gets printed out. That doesn't get printed out either, man. So I'm gonna look at the Codecademy forum and see if there's like something going on with it. Let's see. Okay, so I'm looking at the Codecademy forums, and returning 3 values implies a list or a tuple set back to the caller. So return x, x times 2, x times 3, first 2 multiples, print. Fine. The lesson expects only a single value on return, the third multiple value, and for us, print the values in the loop. No, we never. So we didn't go over loops yet, did we? Yeah. So look, they did the same thing we did. Multiplying is
Yeah.
just simplified addition. So here we can use multiplying to be neat and simple instead of adding them all up. How do we simplify addition? Multiplication is repeated addition just because of the additive property of numbers. What? Okay, so it looks like we were doing it right. So they said that this is just like a super weird exercise. Whatever. Works for me. Let's get rid of this. That's such a weird... Because it's supposed to return 3, right? So can it return hello world like a string? No. That's weird, right?
Very.
Okay. Okay, I think there's something wrong with... Oh, you know what? Here's how we test it. Say my var is equal to first 3 multiples, right? And then we put in the number 10, okay? And then we print out my var and we run it, see what happens. Nope, my var just prints out 10 through 30 again. I don't know. This seems so wrong. Alright, it says we passed it. but I don't know. This seems shady, man. All right, we're gonna create a new file. All right, you get the next one.
That's crazy, man.
Yeah, I don't know. It didn't return the number, right? Well, I wonder if you know what I wonder? I wonder if the return statement, right, should be done before the print statement. Run,
Ah,
right?
well, that
Nope.
didn't matter.
It looks like the return statement kills the code. It's like a break statement. So run. So it looks like it's like a break statement, like break out, break, and then it ends the function. It looks like the return statement leaves. Okay. Inconsistent use of tabs and indentation. So maybe it was an indentation error. I don't know. Nope. So this leaves the code, but it doesn't do anything.
Yeah, should you indent return on the line like a space?
Yeah, but here's what I don't get, man. Like we returned this. That gave us something.
It's indented though. It has the space. You,
Let's get rid of all
oh,
this and let's just return num times 3. See what happens. It doesn't return anything. There, wait, first 3 multiple. I'm making sure I spelled it right. First 3 multiples, 10 becomes number, and then we return 10 times 3, right? We would expect to see 30 returned. Tell me I'm wrong.
no, that looks right.
Okay, so I'm going to test this here. Instead of win percentage, I'm going to put first 3 multiples. .py. What? That first 3 multiple. I must have spelled it wrong, man. No, mul. What I can't spell, dude. Win percentage. Oh, you know what? I bet you this got saved under the projects folder. Yep. No, session 1. First 3 multiples with the number 3. Jesus. Alright, save that. Let's go back and let's try to rerun it. First 3 multiples.py. Dude! Okay, so we're gonna have to look into that. Cause that is breaking my brain right now. Right?
What's in your brain?
Does it have to be like we return an integer 3 or something crazy? Run. Oh, there's an extra parenthesis. Run. No. str? I don't know. Let's just rewrite this. Print num times 1. Copy it. Paste it 3 times. Or twice. 2, 3. And then return 3. I don't know. Num2, what? Unindent does not match any outer indentation level. This is driving me bananas. Look at this. Run. It's because none of these were, let's see. Tab. Shift tab, tab. Run. Okay, whatever. Okay, cool. Moving on to the next one. Dog years. Is this mine or yours?
Is it what
I
now?
feel like this one's yours.
Oh yes. What you trying to say, man? All right. So okay, some say that everyone you whose life equivalent to. Okay. So we got a function named dog years. Taking the parameters name, comma, age, colon. Again, the function should compute the age in dog years and return the following string. Okay. So we want to return the name of the dog, age, years in dog years. Okay, so right, the function should compute the age of dog years and return the following string. Yeah, I mean this is it's showing us the answer.
Is it?
That's what it looks like.
Yeah, I don't know.
Yes, that's it.
So let's do this. And nope. So I guess it wants us to concatenate.
You want to return the actual value though.
Right. So this looks like a substitution value. So yeah. So it returns.
So don't have name in the string.
Right.
Name out of the string, and then there you go, concatenate, and then same thing for age, separate.
Well, age is a number, so remember, what do we have to do with numbers to make them strings?
You have to call this, what is it, the string, you have to convert it.
Yeah.
Convert the number to a string.
str.
And then the concatenation. All right. Okay, looking good. Return name, comma, space age plus years old and dog years. Place. There you go. All right. That looks good.
Well, except for one tiny little thing.
Let me see.
So we have to write a formula to calculate age. Right? Because age in dog years is not the same as age in human years. So the formula...
so like they mentioned, it's 1 year of a human's life is equivalent to 7 dog years.
Yeah.
So okay.
So tell me what to type.
All right. So let me see one function. So we need 1 human's life, 7 years. So 1 human year. So we got to define human life, human.
Well, we're already given that. So human age is age.
Age. Okay. So age is going to be equal to 7 years. Okay, so times that by 7.
Okay.
And that would equal. Let's name that dog years. Dog. Oh, there's the function. Dog _ year.
I mean, yes. I mean, we're gonna cheat. We can just do that, right?
Age equal. Yeah.
I mean, technically, but you are right though. You are right in that, right?
Okay,
you are correct that when you're naming variables should be descriptive in what it's doing, right? And then we would rewrite this, right?
Mm-hmm.
So that is an important point to point out, actually. So even though we could have cheated and said age is equal to age times 7, if somebody else was to look over our code and they looked and they said, oh, dog years is equal to my age times 7 is how they'll read it in their head. If I just said age is equal to age times 7 and you're looking over my code and you had no idea what the hell I was talking about, you would skip over that line. You wouldn't even look at it because you'd be like, I don't know what the fuck that means. Like, let's move on. Sort of a deal. All right. Oh, so that is a good it's a good thing to point out. Let's run this. Prints out correctly. Unit test pass. Go on to the next one. Remainder. Write a function named remainder that has 2 parameters called num1 and num2. The function should return the remainder of twice number 1 divided by half of number 2. Okay, so let's do def for our initialize of our function, remainder of number 1 and number 2. And it's going to return the remainder of twice num1, okay, divided by half of num2. And honestly, it's like half of just like num2 divided by 2, right? Is technically the same. Hi guys. My kids are in the room. Yeah. No, it's okay.
Get out. Jesse, get over here.
Mic off. Mic on.
My kids came charging into the room looking for me. Alright. So this look right? This looks super janky, dude. Does that look right? So half of num2 is 0.2. So let's see. I mean, the remainder, shouldn't the remainder be modulus? We had a function called remainder that has 2 parameters. The function should return the remainder, right? Which is remainder of 2. So the remainder would be this, right? This should print 2. Yeah. Do you understand what I did there? Do you get what happened, Kevin?
Wait, I think I had you on mute.
Oh.
Yeah, I was watching the whole time.
So when it said the function should return the remainder of twice num1 divided by half of num2, all I did was I said num1, twice of num1 is times 2, half of num2 is times 0.5, and to find the remainder, I have to use that little modulus or modulo. And this gives me the remainder of 15 and 14. So this would be 30 divided by 7, right? 7 goes into 30 4 times. 4 times 7 is 28. 30 minus 28 is 2. That's how we ended up here. And then the remainder of 9 and 6, 9 times 2 is 18. 6 divided by 2 is 3. 3 goes into 18 exactly 6 times, so there's no remainder. Whew. All right.
Nice.
And we'll save this one as remainder. So Control N for a new file, Control S. I'm gonna type in remainder.py, paste in the work, gonna save the work, and then go back. And last one, it's all you.
Cool. Okay, we got a function named lots of math. 4 parameters, A, B, C, and D. The function should print 3 lines and return 1 value. Okay. So let's get our function going. Lots of math. With the 4 parameters, A, comma, B, comma, C, comma, D, colon. Okay. So should print 3 lines. The function should print 3 lines. First, the sum. Okay. So the sum of A and B, let's do A plus B. It's going to print that. Next line. Second, you're going to have print D subtracted from C. So D minus C. D subtracted from. Would it be C minus D? They say D subtracted from C.
Oh, D subtract. Yeah, you're right.
Yeah, D minus C.
D's taken away from C. Yeah. Yep.
Right. And third, the first number printed multiplied by the first number printed multiplied by the second printed. Oh, okay. The first number printed percent.
Ah.
So
we have to change what we're doing then.
So we'll have to do a function then, right? Because
Well, it
the
isn't a function.
the first,
We have
so
to
the
store.
result,
Yeah, we gotta store these into
right,
variables.
right. So the result of the first function, the first
Yeah, what do you want to call
equation.
it?
Let's call it sum one,
Deal. Okay.
and then sum two.
It's not really a sum though.
So what?
It's not really a sum though, right? Because we're taking away.
Oh
Yeah,
yeah,
I'm just kidding.
right,
I'm just
right.
kidding. When naming variables, it's important. So we should rename these to something other than someone. Or no. So we can say someone, but then we should rename this to something else. It's not some.
Different, or this, or no, let's.
Yeah, diff one. Whatever.
Okay, there you go, different. All right,
Cool.
all right. So third, the first number printed, multiply. Okay, so we're gonna do the third. Sum one times. You ready? Sum one times diff one.
Yeah.
Finally, it
Third.
should return. So we need a third. We need a third variable.
Mm-hmm. What do you want to name
Do we
it?
need a third variable?
Yeah.
Huh?
Yeah. What do you want to name it?
Let's call it total.
Deal. Total is equal to. Okay. So we have our variables set up. So now we should go back over the requirements and we see. Okay. So we're gonna print 3 lines and return 1 variable. Or so we know we're gonna print, right? You see what I'm doing? So I'm reading over the requirements, and it says we're gonna have to print 3. So here we just store the variables, but we didn't actually print them, right? We actually have to do the printing of the variables we saved. And what was it? What are we returning? What is it?
Returning the third number. So the third number. What the? Wait.
I
Third
think
number.
mod is modulus. So it should return. I think it should return. Mod is modulus. It returns the third number printed modulus A. That's a weird way to word that. Finally, it should return the third number. Oh, so it should return the third number printed modulus A. I get what's
Okay,
going
so
on. Yeah.
total mod A.
Yeah, but is it? Yeah. Okie doke. Let's do our unit test. Oh, in here, like I would put comment print statements, and I would put a comment here that said variables, even though we really don't need them because it's really small. But all right, look at that.
Cool.
Let's do the other unit test.
Awesome.
Look at that. Well done. Wow, that was confusing for a second. All right, cool. So I'm gonna save that as lots of math. Control N, Control S, lots of math.py, and then I'll put this up on the GitHub for review and paste this and save this. Cool, so let's review that one again. So we took in 4 parameters, A, B, C, and D. We added A and B, stuffed it into sum1, subtracted D from C, put it into diff1, and then our total was equal to our sum1 times our diff1. And then we printed sum1, printed diff1, printed total, and then returned the total modulus A, which is the remainder of our total divided by whatever it came in as A.
Right. In that case, it's 1.
All right, that is all for tonight. I'm going to continue on. I'm going to plug away. I'm going to stop the stream, though. Stream is stopped. And I'm going to stop the recording. Hello, and welcome to the next lesson in Python for computer science. We're going to be talking about control flow. Kevin, you want to go ahead break down how you understand control flow while people look at this wonderful chart Code Academy puts out.
Control flow. So, well, as you can see, it's a diagram, right? So, but more specifically, is the different options, I guess, the different pathways that your user flow can go before a action is taken, and each action is broken down into separate options. It's really congested, but the diagram helps to keep up with the control. But all in all, it's just a flow of methods.
Yep. Yeah, I would say the only thing I would have to add to that is that so in computer science, you have conditions, right? And when the conditions are met, you tell the code to execute a certain block of code. Now, if you've done some coding before, you'll recognize this immediately as if else if, right? But there's also control flow also includes states, right? So something could be in a state. And when we say in a state, we mean something could be in a current state of true. So like in a do while loop, you say, okay, execute this code while x is less than 10. And then inside the code will then count x up every time it steps through and add 1 to x until x gets to 10. And then x is no longer equal to 10 or less than 10. So then the state of the code condition becomes false. And then it stops executing that code. So when we talk about control flow, we're going to be talking about true false. We're going to be talking about conditional statements. So I'm just going to go over, I'm going to skip past this real quick. So in this first one, we're going to look at Boolean expressions. So let's see what they want us to do here. So this is just logical. So so we're going to go over logic. So in the step 1, determine if the following statements are Boolean expressions or not. If they are, set the matching variable to yes, and if they are not, set the matching variable to no. And the example to say, my dog is the cutest dog in the world. This is an opinion, not a Boolean expression, so you would answer it no. All right, so dogs are mammals. That's true, so this would be yes. My dog name is Pavel. True or false?
Got a rhyme scheme going.
Is it a Boolean though?
Yeah, I guess.
And
No.
why is it a Boolean?
Well, how do you know for sure the dog name is Pavel?
Yeah, but right, there's only two answers. Either it is Pavel or it isn't Pavel, right?
Well, I think it's no because it can't be proven.
Well, the statement is Boolean though. Logically it's Boolean because either the dog is named Pavel or the dog is not named Pavel. But my dog is the cutest dog in the world is no, that's so I think it's true. You think it's false? Well, we can put no. We can put no.
Yeah, we can put yes because
I
they're
think
saying that's my
I
dog's
don't know.
name.
I've been
There's no
around
reason.
so many times so far, so I wouldn't trust my judgment. Dogs make the best pets. That is an opinion, right? Because there's not two options, right? Because there's many pets. So dogs make best pets. It's not like that could be true or false. Whereas a name is true or false. It can either be a name or it could be the wrong name. Statement 4: cats are female dogs. Ooh, ooh. Boolean, is that a Boolean statement?
Yeah, that's
Okay, let's run it. Let's test it. Okay, so they were all right. So, a Boolean statement specifically is when the thing you're making the assessment against is either true or false. Cats are female dogs or they're not. There's not a third option, right? So that's a Boolean statement. That's a true or false statement. Dogs make the best pets. That's an opinion. Cats make the best pets. Turtles make the best pets. Rabbit makes the best pets. Dogs make the best humans. Cats make the best humans. Turtles make the best humans. Because it's a non-Boolean statement, it's an opinion. So statement 2, my dog name is Pavel, that's a true or false. It's either true or it's not. If your dog's name is Doug, well then the statement my dog name is Pavel is false. Right? So logically looking at it, if something can either be true or false, then it's a Boolean statement. If it's interchangeable, like dogs make the best pets, that's clearly an opinion. All right. Relational operators, equals and not equals. Now this is a bit of a tricky one because I've seen a lot of code, especially at work, where when they want to be absolutely sure about something, they'll run a not statement in front of it, and then they'll write the inverse code. And what I mean by inverse is I mean the inverse of 1 is -1. The inverse of -1 is 1, right? So I just mean the opposite. So if, for example, they want a statement to be true, to only accept true, they'll write the code to say if it is not false. Because not false can only be true. So I've seen code written that way before, which is super confusing. So, oh, look, we got equals equals. Yeah! Describe equals equals to the folks watching at home.
Oh, equals. Oh, so equals is equal, like like a regular equal sign.
Yep. So it's a
Yeah.
it's a comparison, right? It compares. So where the normal equal sign assigns stuff, right? The equal compares the two things that are on the left and right side of the operator. So a normal equal sign will attempt to assign whatever is on the right of the equal sign to whatever is on the left of the equal sign. So that's why. Go ahead.
So equality then.
Yeah. So like here, statement 1 stores cat into statement 1. So this operator is an assignment operator. But if we put equal equal, this would come back false because statement 1 is not equal to cat unless cat has been stored into statement 1 already, which I guess it could be. But it would have to this would have to be equal. So it has to be whatever's on the left, you compare it to whatever's on the right. And then it will either come back true or false back in the code. The code will look at it and it'll say, is statement 1 equal to statement 1? If so, then that's true. Is statement 1 equal to statement 2? State 2? If it's false, it'll come back false. So, and then there's a third operator, but we won't go into that right now. Equal, equal, and good old not equal, which is the exclamation point followed by the equal symbol. You'll see this a lot. Like you'll see like exclamation point, true, and that actually means false. And then you'll see exclamation point false, and that actually means true. So the exclamation point just it's a negation. It means the inverse, right? It means not true. Just like if you were to say not 1, you're saying as long as it's not the number 1. So if you say
Everything but.
yeah, cat is equal to not 1, then that would come back true because cat is not equal to 1. And if you put cat is equal to 1, it would come back false, right? Oh, this can get so confusing, dude. Logical operators. This is like the stuff they give you on like the ACT. So determine if the following Boolean expressions are true or false. Input your answer as true or false in the appropriate variable to the right. All right, you want to take the first one or the second one?
I'll take the second one. It looks more challenging.
All right, so first one, so it says 5 times 2, which is 10, minus 1, which is 9, is equal to 8 plus 1, which is 9. So that's true. And then you do the second one.
13 minus 6. Okay, is not equal to 3 times 2 plus 1. 6. 3 times 2 is 6 plus 7. 13 minus 6. Oh, that's what we say. It's false. 13 minus 6 is equal to 7, which is also equal to 3 times 2 plus 1. It's false. It's saying it's not equal to it.
Yeah, and it is equal to it. Yep. Good catch. Good catch. And statement 3, of course, is 1. 3 times 1 is 3 is equal to 3. And that is true. Hopefully I didn't miss any of my signs there. I don't think. 2 minus 1 is 1. 3. Run. Yeah! So whenever we get this little green check mark on Codecademy, that means it was successful. Let's see. So before we go any further, let's talk a little bit about true and false. You may notice that when you type them in the code editor with an uppercase T and F, they appeared a different color. This is because true and false are their own special type, Boolean. So up to this point, we've only dealt with 3 types, right? We only dealt with floating numbers, which are decimals, numbers, which are integers, which are numbers, and strings, which is characters that are surrounded by quotation marks. Well, there's another data type that we didn't talk about, and that's called Boolean. And a Boolean data type, or bool data type, is simply true or false. Those are your members of the bool data types. Let's see. So it says you can set a variable equal to a Boolean expression. So yeah, so it's very interesting is in Python you can see, so let's do that first example, right? Let's paste it over here. You see that bool1. Here's the assignment operator. So the assignment operator says, okay, everything to the left, assign everything to the right, the expression on the right, to the variable on the left. Well, here we have a comparison operator. So here's an assignment operator, which is just the equals. And then we have a comparison operator. So even though they both have equal sign in them, it's not like an equation. You're not saying like A is equal to B is equal to C. You're saying A is equal to B not equal to C. So if B not equal to C comes back true, then A is equal to true. So let's write that out. So we're saying A is equal to if B is not equal to C, right? And so A can only ever be true or false. A can never be anything else. So when you have a comparison operator, these are the 2 comparison operators, equals equals, and exclamation point equals, it can only ever return back true or false. There's no other option. Okay? That's just how it is. This expression can only ever be true or false. So A will only ever be true or false. And so we won't dive too deep into the logic, because then you can say, is A true or is A false? If A is true or false, then A is true, else false. And what that means is that whatever got stored into A is an invalid. It's like dividing by 0. It's like A is equal to 1 divided by 0. Well, that is neither true nor false. That's just simply an error, right? All right. So now that I've confused everybody, let's clear all this out. All right, let's see what they want us to do. Create a variable called myBool and set it equal to true. The string true? My baby bool is equal to, hey, it says the string. Okay, that's all I'm saying. Okay, check the type of myBool by using type. So they introduced a new method here, which is interesting, called type my baby bool. And when you print it, it should print out string, right? Oh, I have to print it. Shoot. So when we print it, it should kick out string, class string. So this is interesting. This is really interesting. This is interesting, yeah. So my bool is equal to true, and then print type my bool. It should print out class boolean. Okay, cool. So they introduced us a new method called type, kind of like how we did the str to convert things into strings, and int to convert floats into numbers. Well, we have another method here called type, which will look at whatever it put into it and then determine which class it belongs to or which data type it belongs to. So that's pretty cool.
So let's do another example of that type.
Which type?
Create a variable. No, I mean just like just testing it out.
So give me an example. Tell me what's the type.
Create a
Create
variable
it.
name onto it. You can check it out.
Probably do a number.
Huh?
Do a number.
Yeah, let's just do a number because we already did strings before. So random number.
Random number. And there it goes. It prints out int. So if we take this number and we make it a decimal, I bet it makes it into a float. And then if we remove the decimal, it makes it into an integer. Remember, we're still printing out the string from here. So we're still gonna, and then if we put it in quotes,
it's gotta be a
string.
String. Okay.
Yeah.
Nice.
So that's interesting. I didn't know that method existed. Great. And again, methods are predefined functions that are built into the language. The methods belong to the class. So there are certain methods that the string class has that the integer class does not have, and there's some methods that the integer class has that the string class doesn't. So just remember the methods are being defined by type. It's usually the name of the method followed by parentheses, followed by the parameter that you have to put into the method. A method is just a function. There's nothing fancy about it. It's just that function belongs to a specific class, which means other things that are not part of that class cannot access that method. We'll get into this later on when we start writing classes. Alright, so what am I printing out here? I'm printing out a type. So make another parentheses and type. And then my baby bool 2. I'm gonna run it. Uh-oh, I did something wrong. What did I do? Double paren, single paren. Oh, jeez Louise. Ah, it's so hard. Codecademy's code editor is not like top notch. So my baby bool type and then that and then run that. Hey. Okay, next. If statements. Yes. We're starting to get there.
Check your modem or router connection and try again.
So if it is raining, then bring an umbrella. So an if statement checks if something is true or false. And then if it's true, run the code that's underneath the if statement. If it's false, skip it. It's the easiest way to think about this. So let's just get right into it. So in the workspace script.py, there's a function, functions again, with an if statement. I wrote this function because my coworker Dave kept using my computer without permission, and he's a real doofus. Great. So it takes a username as an input, and if the user is Dave, it tells him to stay off my computer. Enter a username in the field for username and try running the function. So here we're going to pass in username. We're going to say Jeff. We're going to run the function, right? And apparently something, what? Invalid syntax. What? Let's reset this code. Let's reset that. Let's try it again. Because that's their code. So it's saying that there's an invalid syntax with the if statement on the code that they wrote. Like, we didn't write any of this. They wrote all of this. So what
On
I'm
line
gonna do,
2?
so right here.
Yeah.
So there should be a tab here. So let's do this. Tab. And then there should be a tab there because the return has to fall. So when writing an if statement, so in a lot of other languages, an if statement would be written like this, like if true, and then brace, right host, yes, sort of a deal, like where you'd put the parameter in parentheses and then put braces, or braces. But in Python, it's just like a function. The if statement goes underneath the function, and then you end it with a colon, and then the next line has to be tabbed over underneath the if statement to belong to the if statement. So it's interesting that invalid syntax is equal. If the username is equal to Dave, maybe. Right? Because this has to do a comparison, right? Do you see why that was wrong? Because this is an assignment. This is a comparison. So we fixed it because username is supposed to be compared to Dave, right? And then return, get off my computer, Dave. Inconsistency use of tabs, spaces, and indentations. Okay, so let's do this. 4, enter, and let's rerun it. Oh, so there's something wrong with their terminal. I'm gonna refresh the page. There's just something going on with Codecademy. We had literally nothing to do with any of this. Let's run this. Let's reset. Let's do the comparison operator. If it's Dave, right? And let's put Kevin in here. And let's run it. And it prints out none. So it doesn't have an output to get back to us. It has an if statement, but it doesn't. If the if statement is false, right? Because username is equal to Kevin right now, right? So this is a Dave check function, so it runs this function, and it inputs username. Well, username was defined as Kevin, so it passes Kevin to here, back up top into here, and then to here. So Kevin becomes username, and then it says if Kevin is equal to Dave, then return get off my computer, Dave. Well, obviously Kevin's not Dave, so it skips the if statement, and then it doesn't do anything. So we can confirm that by putting Dave's name in there, and then it prints out the if statement. It says, oh, Dave got a run. Go ahead.
No, I'm just saying that's awesome.
So it says Dave got around my security and has been logging onto my computer using our coworker Angela's username. Update the function with a second if statement, so it checks the username as well. So this is super simple. We're gonna create another if, and we're gonna check the same thing. If username is equal to, and we're gonna use Angela Cat Lady 87. Okay. Then we're gonna tab. We're gonna return. I know it is you, Dave. Go away! Exclamation point. And we'll run. And if we forgot the colon. All right, I forgot the colon. Let's rerun it. And then to unit test it, we'll put in Angela's name. Angela Cat Lady 87. And we hit run, and forgot a quote.
End up line.
Yeah, I forgot a quote, and now it runs the second if statement. And we'll hit next. Okay, so relational operators 2. Yeah. So comparison operator, right? So we have assignment operator, comparison operator, and relational operator, which is the greater than, less than, greater than, equal to, less than, equal to, which can also technically be a comparison operator. Like you can say, is 1 less than 2? Well, that gives back true. So relational operators and comparison operators are sort of from the same family, right? And so you can see the function they give here. So the function age check passing in age is the parameter. If the age is greater than or equal to 13, return true. Nothing crazy going on there. So we're going to write a function called greater than that takes two integer inputs x and y and returns the value that is greater. If x and y are equal, we're going to return the string. So let's first write that function. Def greater than, and it's going to take an x and a y, and we colon, and we say if this sucks because we don't have an else statement yet, so they're expecting us to write if x is x and y and returns the value that is greater. Oh, okay. What? If x and y are equal, then return the string. Okay, so this sucks because we already know that there's else statements out there, right? So like we already know that you would say if x is greater than y, then return x, right? And then we would say else if. We would normally say else if, like else if x is equal to y, then return these numbers are the same, right? And then we would say else you would just return return y, right? Because if x is the only possibilities are that x is greater than y or x is equal to y. And if x is not greater than y and x is not equal to y, then y is the greater number. That's the only other possibility left, right? So if we look at it from a mathematical standpoint, x is greater than y is either it's true or false. Same thing. X is equal to y is true or false. And then y is greater than x only if x is not greater than y and x is not equal to
So
y.
what are you doing down there? Like you just
So I'm just showing you the logic behind it.
Oh, okay.
I'm saying these are our only options, right? X can only be greater than, equal to, or less than y. But we don't need to say if, like, so when we code, we don't need to say if y is greater than x, return y. Because the only possibility left is y at this point, after these two statements come back false. If both of these statements come back false, then y is greater than x. It just has to be. So those are sort of like little logical exercises. This is not how they want us to do this exercise though. So we're going to do it the way Codecademy wants. And the way they're going to want us to do it is if y is greater than x, return y, and then if x is equal to y, then print these numbers are the same, right? And we can test this. Hair dog. All right, so we can test this by calling the function. In this case, so when you write these functions, how many unit tests do you need for this right now?
How many unit tests? A couple, like 1 and 2.
Well, just looking at it. I mean, just looking at
Oh, wow.
you can count how many unit tests you'll need, right?
We need 3.
You'll need at least 3, right? That's why, like, I can't stress this enough. You want to keep your functions to as little, the lowest amount of parameters you can, because the more parameters you add, the more unit tests you need to do for that function. So if you have, so here's the problem with PowerShell, right? So I do a lot of PowerShell scripting, and it's native to Windows, and there's a lot of PowerShell scripters out there, right? The problem is, I would say a majority of PowerShell scripters are not developers or computer science majors or engineers necessarily. So they create functions that have like 5 parameters in them, because to them they don't test their code. They don't need to test their code because they're writing a customized script that does what they need it to do. And so they know what their parameters are going to be, and they think that their parameters will never change. When in reality, if you look at their function that takes 5 parameters, it really should be split up into 3 functions. One function that takes 2 parameters, another function that takes 2 parameters, and one function that takes 1 parameter. Because when you unit test, you only have to write 2, 2, and 1. Yes, you only have to write 5 unit tests. Whereas if you take in 5 parameters, right, the possibilities are 1 parameter, 1 unit test, 2 parameters, 2 unit tests. Now we're at 3 unit tests. By the way, if you're keeping the math, right? 3 parameters, so it's a factorial almost. So 5 times 5, you need 25 unit tests for a function with 5 parameters. In some cases, just keep the functions. Keep them to 1, 2, at the most 3 parameters. Right? That's my suggestion. Okay, moving on. I'm off my soapbox now. Okay, so we can write the unit test down here, and oh my gosh, it's still indented. Crazy. So we know that the first unit test, we want x to be greater than y. So let's just do this. We're going to say the first unit test we're going to call greater than, and we're going to pass an x is greater than y. The second one, we're going to pass in y, or x is less than y. And then the third one, and I just realized I misspelled this. Didn't I? Or no? Great. Yeah, I did. We're going to make x and y equal. And so all you QAs out there, you're going to write should return 3. Okay? Because x is 3, and so if x is greater than y, which in this case y is 1, it should return 3, right? And then should return, the next one should return y, which is 3, okay? And then should return string. So let's run this, and let's see. Expected greater than with test inputs 1 and 1 to return the numbers are the same. I don't care about that. Did I misspell greater than here? Greater than 3 and 1. Let's do this. Let's go. Oh, you know what? It didn't actually return it returned a value, but I hate it when it does this. So we would write value is equal to, and then we would print value. I think print value, right?
Yeah, I'll be right back.
Okay. And should return 3. We should do the same thing here. We should say value 2 is equal to this. And we print, because we're doing a return and we're not actually doing a print statement, we have to do it this way. And then greater than 3 doesn't need to be variabilized. So to do these unit tests, what we had to do was because these are returning and they're not printing, we had to store them into a variable and then print out that variable. Okay, so we should expect to see 3, 3, and then the string, and we see 3, 3 in the string. Then we know that these unit tests passed, and we can comment those out. And these would be our test cases, right? And so let's see, write a function. Let's run it. Expected greater than with test inputs -9 to return. These numbers are the same. Let's run. What? Did we do something wrong? If x is greater than y, return x. If y is greater than x, return y. If x is equal to, yeah, that's right. What's it saying? Expected greater than with test inputs 5 and 5 to return these numbers are the same. They would be. 5 is greater than y. Fail. Y is greater than. If x is greater than y, if y is greater than x, return y. If x is equal to y, print. Let's refresh this page. I think something's wrong. Codecademy again. Run. It takes 2 integer inputs. If x and y maybe equal, run. Oh, it doesn't use the equal operator. That's only JavaScript, I guess. Yeah, -8 and -8 should be equal. Can I just put else? Can I just cheat and put else? That would be so much easier. Is that not how we write an else statement? Oh, inconsistent use of tabs. Come on. Alright, let's rewrite this. Return y, else, print. Are the same. Run. -5. Well, we can test that, right? We can say greater than -5, -5. And we can run it. Yeah, it passes. This is so ridiculous. Look, it actually passes when you evaluate these numbers. So if you evaluate 3, and we evaluate 3, we run it, it gives us back the string. So you wonder why if did I miss a colon? Run it. Inconsistent use of tabs and spaces. What are they talking about? This makes no sense. So we shouldn't return anything. We should print the statement. Let's run it. 9 and 9 do return these numbers are the same. I think they're like if we put in the test cases here that they were trying to use to test this, I think there's a flaw. Look, it returns. Oh, it says -6 and -6 now. You put in -6 and -6, and it prints out the statement. So there's something going on with their code. Remember, you define a function using the def function name. Did it tell us to test this? Let's see. Write a function that returns, yeah, so we did everything. Also make sure you're copying the response exactly. Okay, maybe that's what the problem was. These numbers are the same. Nope. So let's see if anyone else is having these problems on the forums. There's no output from the above code. The value is returned to the caller and everything ends there. To see the return value, we must print it or at least assign it to a variable. Retrieve it and then print it later. This is not... So, if x greater than y, return x. Wow, that's if y greater than x. If x, these numbers are the same. So, did I do that? It returns. They didn't print it. So they wanted it returned. Oh my goodness. So they wanted return the string. See? Didn't follow requirements, guys. And I got stuck. So you have to follow requirements. The nearby college, Calvin Coolidge College, or 4C, requires students to earn 120 credits to graduate. Write a function called graduation. So let's write a function called graduation recs that takes an input credits. All right. And checks if the student has enough credits to graduate. If they do, return string. Okay. Oh, 120. So we have to say if credits are greater than or equal to 120, right? Return you have enough credits to graduate. And run it. That's good. All right. Call graduate recs with an input of 120 and print the result to terminal. Can a student? Yes, right? The answer is yes, by the way. So what they want us to do is print the resulting from the function.
Yo.
What's up? Graduation recs. See, what happened was they tried to trip us up. They want us to create a function that counted credits, and if the credits are greater than 120, they can graduate. But I knew it was going to be greater than or equal to, because here it says the nearby college, Calvin Coolidge College, requires students to earn 120 credits to graduate. Write a function called graduation recs. Take the input credits and checks if the student has enough credits to graduate. So it has to be, are the credits greater than and include 120? Then that's greater than or equal to. And so we'll print graduation recs and we'll print out 120 and run that, and it says you have enough credits to graduate. So we just created two functions. Also, I found out why my stuff was failing, because I was supposed to return the value. I guess when they do their unit test, they're looking for a return input, and I was printing out this last statement, which was wrong. Boolean operators and. So the and, or, not, nor. So we're going to start with and. So let's look at the example here. 1 plus 1 is equals 2, and 2 plus 2 equals 4. This is true, because both sides are true. When you see an and operator, I'm sorry, is it an operator? Or, yeah, it's an operator. It's a type of Boolean operator. If you see an and statement, the left of the and the right of the and both must be true for the whole statement to be true. That's how you can remember and. If one side's false, the whole thing's false. If the left side's false, then it returns, the whole statement returns back false. If the left and the right of the and are both false, it returns false. If just the right side is false and the left side is true, it still returns false. The only condition that an and operator returns true is if both the left and the right side of the operator are true. And you see that in this example. This is false because 0 does not equal to 10, and 1 plus 1 does not equal 1. 1 is greater than 0, or 1 is not greater than 9, even though 5 is not equal to 6. This comes back false because if one side is false, the whole thing's false. So let's practice. I want to take this one. State 1 is not equals to the following.
Yeah.
So it's all right. Do that. Tell me what to put for statement 1. Is it true or is it false?
All right. So we got 2 plus 2 plus 2 plus, okay, so we got 6 is greater than or equal to 6, and -1 times -1, which is positive 1, is less than 0. So that's false.
So is
One.
the whole statement true or the whole statement false?
The whole statement is, what's that, less than? That's false. The whole statement is false.
Yep. And that's the beauty of the and statement. If you read this first part and this first part is false, you don't even need to read the second part. You already know it's false, right? In this case, the left side was true and the right side
Right.
was false, but we don't care. For an and to work, both sides have to be true, which I suspect which will happen in this one, right? So 4 times 2 is 8, which is less than or equal to 8. This is true. 7 minus 1 is equal to 6, and this is true. So since both sides are true, statements, the whole statement's true. Okay, so let's run this. And we were correct. And it says, let's return to college. 120 credits aren't the only graduation requirement. You also need to have a GPA of 2.0 or higher. So rewrite the graduation recs function so it takes 2 inputs, GPA and credits, and checks to see if the student meets both requirements in an and statement. So go ahead, Kevin. Lead me. Walk me through how to rewrite this function based on the requirements given.
Right. I have to reread it. Okay. Rewrite the graduation requirements so that it takes 2 inputs. All right, so we got a function. Okay, we got the function already. Graduation requirements, credits, takes 2 inputs, GPA and credits. So we're missing GPA in the parameter there, GPA comma, and checks to see if a student meets both requirements using an and statement. Okay, so that it takes 2 parents to see if the student meets both requirements using an and statement. So if credits and GPA is greater than or equal to 120, that will complete the statement.
So we have 2
If they
statements.
do.
Yeah, remember we have 2
We have
inputs. We have 2 statements.
Immediate else, right?
Yeah. So this statement is credits. So then we write and then what do I have to write for the GPA statement?
Oh, okay. GPA. Okay, if GPA and GPA 2 is greater than 2.0,
Okay.
and then you need a second.
You missed a requirement. Is greater than equal to.
120 GPA of 2.0 or higher. Okay, right. It's greater than or equal to.
So
Got me.
it has to include 2 as well.
Yeah.
And let's run it. Oh wait. Expected graduation recs with the test value GPA 2 and the.
So you have to change the string.
Are you sure?
No, we need an if else statement.
No, we don't.
No?
Well, you know what? I wonder if we. Do you think we have to put these in parentheses? Hmm? Je ne sais. Je ne sais pas. I wonder if when we're doing an and statement, it requires us to wrap these in parentheses. I do not know. This is just a theory.
Well, yeah,
And
that
it
makes
is a
sense.
wrong theory.
No?
Alright. So, you have enough credits to graduate. Credits, if the credits are greater than or equal to 120, yes. Right? Yes. Yes. And the GPA is greater than or equal to 2.0. What are we missing? What are we missing? No, that's right. That's right. So 120 credits aren't the only requirement. You also need to have a GPA of 2.0 or higher, which this matches, right?
Does the credit, so the credits doesn't have to be greater than or equal to, right? Yeah?
It does from the first requirement. The first requirement says you need at least 120 to graduate. So your credits have to be greater than 120 or equal to, and then your GPA has to be higher than 2.0. So expected graduation recs with the test values GPA equals 2 and credit equals 20 return you meet the requirement graduates. So what's interesting is we could test this, right? So let's test it. Unless I spelled graduation, which is possible. Graduation recs. Graduation recs. Right? And then we can enter in the GPA, which is 2.0. And then we can enter in the credits, which is 120. Right? And then we can print this out in a print statement. We can end it. And then oh, I hate that the editor auto assigns parentheses. Let's run it. Ha! It passes! So here's what I'm thinking, man. I'm thinking that they want the parameters to literally be like this.
Yeah, but you have to return the string. You meet the requirements to graduate. Not you have enough credits. You see on line 7, it says you have enough credits.
Oh, you meet the. Oh, you're right. Ah, see? And this is why you have to pay attention to requirements, which I keep saying. And I'm not doing. Ah,
Right.
requirements. That was a good catch, man. Solid.
Yeah.
Okay, so or statements, really quickly. Or statements. Either the left side or the right side has to be true for the whole thing to be true. So in the and statement, everything had to be true. And in order for the whole statement to be true. With an or operator, either side has to be true for the whole thing to be true. So it's not necessarily the opposite of an and statement, but it pretty much it ignores any false statements. So if the left side's false and the right side's true, then it's true. If the left side is true and the right side is false, then it's true. If the left side is true and the right side is true, then it's true. If the left side is false and the right side is false, then the whole thing's false. So the only condition in which an or operator is false is when both the left side and the right side of the or statement is false. So let's dive right into it.
Cool.
So go ahead and knock out number 1. And I'm pretty sure number 2 is probably the opposite of number 1.
Awesome. So we got 2 minus 1, which is 1, and it's saying that is greater than 3, which is not. Or negative 5 times 2. Got positive 10. Well, negative 10 is equal to negative 10. So the right side is true, the left side is not. So that's true.
Yep. And then we can look at the statement 2, and we can look, it says 14 is less than or equal. This is true, right? So We know it's true. So the cool thing again about the OR operator is if the left side is true, then the whole thing's true, right? And as opposed to the AND operator, which is if the left side's false, then the whole thing's false. So you can just stop once you get a true statement in an OR operation, then you know the whole thing's true. Okay, so let's see. The registered office at the Calvin Coolidge College has another request. They want to send out a mailer with information about the commencement ceremonies to students who have met at least one requirement for graduation, 120 credits and 2.0 GPA. Write a function, okay, called graduation mailer that takes two inputs. It takes GPA, and it takes credits. And checks if the student has either 120 or more credits or GPA or higher. If so, return true. That's kind of easy, right? Right? GPA. So if GPA, right, is greater than or equal to 2.0 or credits is greater than or equal to 120, then return true. Run. Bam. Easy peasy. Oh, lemon squeezy. All right, cool. How many more of these we got? Woo! Oh, we're almost there. We're in the home stretch. Boolean operator not. The final operator recover is not. The operator is straightforward. When applied to an expression, it reverses it. So anything that was true becomes false. Anything that was false becomes true. It just creates the inverse. Okay. So not true is false and not false is true. Don't get confused. Okay. So let's look at let's do this again. You want to go ahead and knock out statement 1?
Cool. Not 4 plus 5 is less than or equal to 9. So it's false.
Yes. So what's another little piece of information, computer science, that you should be aware of is something called Polish math. So Polish math is a type of mathematical operation in which the math is written in a series of parentheses, and you calculate the total from the innermost parenthesis. So I'll show you an example to the outermost parenthesis. So it looks something like this.
You say Polish math?
Polish math, yeah. And it ends up looking something like this. In which you do x plus y first, and then you would add 1 to it and subtract 77 from it, add 1 to it and multiply it by 99. So this is common in a language called Lisp and C-Lisp, which are super old programmatic languages that use like subroutines and stuff. But they also use, it's also used in AI. So if you delve further into this, you're going to see stuff like this. Well, that's what the not operator is. It's part of that mathematical operation. It says do everything first and then check if that's true or false, and whatever that is, switch it, flip it, invert it. So we said that statement 1 was false, and then 8 times 2 is 16. Which is, this is false because 20 minus 6 is 16, and this is saying not equal to. 16 is not equal to 16 is a false statement, and the not operator in front of it switches false to true. So there's actually 2 flips here. The first flip is here, and the second flip is here.
To be and what not to be.
Yeah, so we'll run this, it'll pass. Okay, let's see what they want. The registrar's office has been so impressed with my work so far that they have another task for us. They want us to return the first function we wrote, graduate rex, and add several checks using and not statements. Okay. So the first requirement, if a student meets both requirements, the function should read. Okay, so This is simple enough. Let's do the first requirement. If the GPA is equal to or greater than 2.0, I put minus there, I don't know why, 2.0, right? And credits, wait, isn't that what we did the first time? It's already written there. Why am I rewriting this? Crazy. Okay, we don't need to do that. It was already written for us. Okay, if the student's GPA is greater than or equal to 2, but they don't have enough credits. So let's just copy this statement. How many times do we need to copy it? Let's see. 1, 2, 3. Okay, so first requirement. If a student meets both requirements, we should return you meet the requirements to graduate. So this is the first one. So we're going to say requirement 1. Okay, this is going to be requirement 2. In requirement 2, it says if a student's GPA is greater than or equal to 2, but they don't have enough credits, so credits are less than 120, not less than or equal to, but less than 120, then we should print out you do not have enough credits to graduate. So let's copy. You do not have enough credits to graduate. Let's paste. And we're missing a quote. Put a quote. Okay, so that's requirement 2. That has been met. Let's go to requirement 3. Requirement 3 says if they have enough credits, but their GPA is less than 2, then let's do that. So if the GPA is less than 2, and return this. Okay, so I already noticed that I made a mistake here. So if the GPAs is, there's an OR statement here, and I have an AND. So this one is OR, right? And this one is OR, right? Because only one of these has to be true, right? And the, well, no, that's not true. If the GPA, no, this is wrong. If the GPA is less than 2 and the credits are greater than or equal to 120, if the GPA is greater than or equal to 2, and, I was wrong actually. I confused myself. These are all AND statements because they give us back specific answers. And also this return statement should be tabbed in. Why aren't these tabbed in? Okay. I don't know why. Is it me or is that these if statements off as well? Holy smokes. This is why we need an editor. Okay, if. Yeah, these if statements are way the hell off, dude. So here's what we're gonna do. We're gonna reset everything.
Yeah, it's just
Well, the return statements are gonna be reset. And then these if statements need to be brought back out 1 backspace. Oh my god, why? Right? This is the worst editor ever, dude. Shoot, what I'm doing is I'm backing them out till they turn white, and then tabbing them till they turn blue. And that should center up all of our statements. And then obviously this return statement is wrong. It's white, so now it's blue. Blue, blue, blue. Okay. Jeez Louise. Okay, so let's see. Your GPA is not high enough to graduate. So finally, if they do not have enough credits and their GPA is less than 2, if the GPA is less than 2 and their credits are less than 2, they should not graduate. Let's run this. Unindent does not match any outer indentation level. Here's what we're going to do. We're going to cheat. We're going to grab all this stuff. We're going to copy it. We're going to bring it over to Visual Studio. We're going to paste it all. We are going to shift all this up. And we're going to hold down shift and press tab. And then we'll press tab once. Okay. Then we're going to go to return statements and we're going to hit tab on the return statements. And then we're going to highlight everything. And then we're gonna come back to Code Academy.
Yeah, Python, that's the thing, man. It's like writing an essay. Like you have to have the right
Formatting.
indents. Yeah,
So
you know.
there are a bunch of programs out there that'll do it for you. There's something called Flake 8, and then there's something called Black, and both of those are formatters, and they will just help you create the code. So, and this statement's wrong actually. You do not meet the requirements to graduate. So let's rerun this. So we have an error. So expected graduation recs with a GPA of 0 and credit 0 to return. You do not meet either requirement to graduate. If the GPA is less than 2 and credits is less than. Was that it? That was it? So let's recap. Requirement 1 said that the GPA had to be greater than 2 and credits had to be greater than 120. The second requirement, GPA had to be greater than 2, credits less than 120. Third requirement, GPA less than 2, credits greater than 120. And finally, the last requirement, if your GPA was super low and your credits were under 120. So you just don't have just don't meet the requirements. And honestly, if you look at this, their requirement says if they do not have enough credits, which is under 120. No, we did that right. Cool. Else statements, yes. We almost have like the basics down now. I'm excited. So an else statement just gives you a second option to if. So if the condition hits the if statement and it cannot be processed because the if statement is false, it will skip the if statement and go to the else statement, and the else statement serves as a default statement. So let's go ahead, and the college has another request, wants you to add an additional check called to the graduation recs function. If the student is failing to meet both graduation requirements, they want the function to return you do not meet the GPA or credit requirements for the graduation. So instead of writing if your GPA is less than 2 and your credits are less than 120, we can just write an else statement that returns this string. Well, bam, and run it. And we're good. And click next. Else if. So, how would you describe else if statements? Like, what's the difference between an if statement and an else if statement? Or elif statements, I should say.
So an if statement, you're gonna have two conditions. Well, one condition. Sorry. A else if statement, you're gonna have two conditions. So if Apple equals $1, do this. That's the if statement. And then else if, you're gonna have if Apple is greater than $1, print this. Else, if it, or let's say if it's not, or say less than $1, do this. So it's just two conditions to verify your.
So why not put two if statements then?
Why not two if statements?
Yeah, why not? So because if the first if statement fails and it goes to the second if statement, why not put two if statements? So if 1 is greater than 2, and then if that's false, then it goes to the second if statement, right? So why not two if statements? Ooh, I got it.
I believe, wouldn't that cause an error? Like, I've never put two.
We could try, right? So we can write an if statement if 1 is greater than 2.
Well, it goes down in order.
It does.
So, yeah.
Right, so if 2 is greater than 1, print. Bye. Run. by, right? So I will tell you that if and elif may appear to be the same on the surface, but really what you want is your so these are not siblings, right? So these are independent from each other. They're not connected in any way. Simply, if this statement, okay, runs and fails, the code moves on to this statement. But these are non-relational statements. This statement here, put a little caret here. This is a non-relational. These are non-dependent nor relational. So these two if statements should and could have absolutely nothing to do with each other. So even though the if statement 2 is greater than 1 is evaluating, yes, a number and another number, they're completely independent. If you're writing code and you want to write relatable code that's related to each other, you use the elif statement, right? And you're like, well, why the hell does that matter? It matters. What this elif statement is saying is that this if statement is related to this elif statement. Okay? It's saying that this chunk of code that I'm highlighting here is all related to each other. They're all processing some behavior together, right? The if statement is going to try to make the first thing work. If it can't, the second statement's going to try to do another thing to it. And finally, if it can't figure it out, it'll run to a default block and it'll print out. So this would be considered an operation. So this is one operation. This if statement starts a second operation. And I see this in PowerShell all the time. People just writing like 15 if statements. And they're not using else if because they're like, well, why use else if? If does the same thing. At a low level, yes, it does. It as you can see, we tested it by printing out by, right? If you rerun this again, syntax error under. Oh yeah, because I put these little symbols here. If we rerun this, it prints out by, right? Twice. What this statement is doing is telling you that this block of code is all related to one operation. And this chunk of code, this other if statement, is beginning a different operation. Right? So, can you get away with writing a bunch of if statements? Yes. Should you? No. Right? Because I can write code that goes and measures an if, elif, and else statement, and it can count from the if statement to the else statement, and it will determine how big that operation is without ever looking at your code. If you just write 50 if statements, and I have a test case, I have code that's testing your code, it'll return to me and it'll say I have to write 50 automated unit tests for 50 different operations. When in reality, it's one operation that can flow 50 different ways. So the automation test code will, like if it automatically creates the test, it will try to create 50 tests for 50 if statements. Whereas if you have an if, elif, else, it'll look at that. It won't make 3 unit tests for that. It'll say, okay, cool, this is one operation. I just need to put one operational input into it. But bam, here's your automated test case that covers all 3 scenarios. So I will say, on the surface, if statement, you can chain if statements and get away with it at a low level. But at a high level, you for now, until we get to switch statements, you wanna use elif. So let's reset the code here. Yeah. Was that confusing at all?
A little bit.
A little bit, yeah. Uh, just follow along. We'll get it. So it says that they want us to write a function called grade converter. Simple. Def grade converter. It converts a GPA into an appropriate letter grade. Your function should be named grade converter, and it should take GPA as the input, and it should convert the following. Oh, this is such a switch statement too, right? You look at this. When I see a list of numbers like this, I think switch statement, which I assume is going to be the next thing we're going to go over. Okay, so we're going to say the first requirement is if GPA is greater than or equal to 4.0, okay, then we should return A. So we're going to just copy and paste this for B, C, D, and F. And as you can see, look, it does this stupid thing where it puts an automatic indentation on it. So again, I'm going to bring it to Studio Code. And I'm going to delete this. I'm going to paste it. I'm going to Shift Tab everything over. And then I'm going to tab everything back out. I'm going to recopy this. I'm going to go back to Code Academy. I'm going to repaste it. Everything looks a little bit cleaner. I'm going to run this. Indentation error. Look at this. Oh, all the return statements need to be tabbed. That's what ended up happening. Ah, it's so annoying, dude. Okay, so because we're coders, we're cheating a little bit. We're saying, okay, we know this is B. We know this is C. We don't want to have to retype code, guys. Like, I can't stress that enough. Cheat as much as you can. So this is 0.
As much as you can.
Huh? Cheat on, yeah. You want to copy as much code as possible. Like,
Oh yeah.
right there, I like copied A and I just put it down all the way to F and I just changed the letters. And so if we look, let's make sure. So 4 and higher, 3 or higher, 2 or higher, 1 or higher, 0 or higher. But bam, let's run this. See what we get back. We get a check mark. We wrote everything good. That's control flow. So if you have a GPA that's 3.5, A will be false. The first one will be false, and it will jump down here. Now, what's interesting is what we should be doing is we should be writing it like this, right? And then here we just write else return F, right? And then we run the program and it passes again. So this is actually the real way you're supposed to do it because again, this is one operation. We are comparing one thing. So we're not taking this and turning it into another. We're not performing multiple operations. We are, but we aren't. It's going through and it's checking the first if statement. Then it's saying, okay, move to the next elif. And that way, yes, it's doing multiple operations. But this is all one related operation. So finding what we should return as a letter grade itself is an operation. Because it's only going to possibly return A, B, C, D, or F. And those are all related to each other because they're considered grades. So that's why we put the elif and the else's, and we shouldn't chain it with ifs. All right, so the try and except statements. Okay, if, elif, else statements aren't the only way to build control flow in your program. Hold on a second, I'm going to pause this real quick. Recording. All right. So, okay, so try and accept statements. Interesting. They're not the only way to build control flow. You can use try and accept. So the first statement under try will attempt to be executed if at some point an exception is raised, such as a name error or value error, then the exception matches the keyword in the accept statement. Then the try statement will terminate in the accept. Okay, so this is error handling. So this is how we're going to write errors out to let us know when something went wrong. So it serves a purpose. It raises a value error. Try running it by entering into the code enter. Okay. So this is a function that they wrote that generates an error. So this is cool. So let's call this function and run it. And it writes a value error. So this is how you'll so error handling is when you write a block of code and the code breaks, meaning some weird input got into it and the code's not behaving the way it should. So it ends up giving you, in this case, a value error. You can write an except, you can write a try that will attempt to create an operation. And then if that operation fails, it will move on to the except block. And the except block will print out a message that you can write. Or in the except block, you can attempt to try something different in order to get that code to pass pass a value. Now I come across this stuff all the time in infrastructure, right? So for example, try to ping a computer. If you cannot ping the computer, then exception, try to ping Google. If you cannot ping Google, then write an error to me telling me that my computer is not on the network. Or if Google is pingable, write an error to me telling me that the computer I was trying to reach is not on the network. So that's an example. So it says write a try statement and an except statement around the line of code that executes the function to catch a value error and make it an error message. Print you raised a value error. Cool. Around the line of code that executes the function. Oh, so what they're saying is here we write a try statement. And I believe the try statement, yeah, is a colon. Okay. And then if it throws an exception, we write an except. And what do they want us to do? You raised a value error. Let's run this. Hey, that's all that was. Have you come across something like this in JavaScript? Did you do Vue.js or whatever? Did they have error handling in it?
Error what?
Did they have error handling in Vue.js?
Not that I know of.
No? Have you done error handling before?
No.
Okay. Unfortunately, doing a bunch of scripting, I've come across error handling. Or the lack of error handling, I should say. So this throws it, that's cool. This, I'm sure we'll get deeper into this later on. We shouldn't worry too much about this, but it's a complex topic, but it's a very important topic because when your code breaks, you want it to give a good message of why it broke. And then if you if you can think of why a piece of code will break, for example, say like in order for this piece of code to work, it first must connect to a server and then download a bunch of files, and then the function does a bunch of work on those files. Well, if you can't connect to the server, you need to throw an error that says you can't connect to the server. So I'm not even going to try to do any work on the function will never run because it can't even connect to the server to run the function because it didn't download the files. So you would want to know that you're not connected to the server. And then you would check your firewalls, or maybe the server's off the network, or you're not on the network, etc., etc. And you could write that all into code. Into the code, you can say, okay, try to ping the server. If you can't ping the server, try to ping out to Google. If you can't ping the Google, then you're not on the network. If you can ping the Google, the server's not on the network. If you can ping the server and you can ping to Google, then you're not able to download the files correctly. If you can't download the files correctly, try to go to a different file server and download the files. And you can kind of see how this kind of like the code will grow and get bigger and bigger as you follow these different forks in the road trying to satisfy the requirements. And you can sort of see the applications start to develop in your head while you're thinking of all these possible routes that your code can take. All right, so we're at the end. We made it through 2 sections today, which is awesome. Well, we did 11 function 11 functions followed by an entire thing here. So let's see. This is a review. So let's see what they want us to do here. Wants to get a piece themselves. They've been inundated with applications and need a way to automate the filtering process. They could collect 3 pieces of information from each applicant: their high school GPA on a scale of 0 to 4, their personal statement, which is given a score of between 1 and 100, and the number of extracurricular activities they participate in. The admission office has a cutoff point for each category. They want students to have a GPA of 3 or higher, a personal statement with a score of 90 or higher, and who participate in 3 or more extracurricular activities. Okay, so here we go. Here are the requirements. Write a function called applicant selector. Which takes 3 inputs. Oh, we're pushing it. We're pushing it. GPA. It's going to take the PS score. And it's going to take the EC count. Cool. If the applicant meets the cutoff point for all 3 categories, have the function return the string. This application should be accepted. So we already know that it's going to be an if statement. And the if statement is going to have if the GPA is greater than or equal to 3, right? And the PS score, I put them in parentheses. You don't have to put them in parentheses. Score is, let's see, greater than or equal to 90, right? And the EC count is greater than or equal to 3, then we are going to have the function return the string this applicant should be accepted. And with a period, obviously. Cool. So that's the first set of requirements. I don't know. Look at this. It automatically puts 2 quotes. Whatever. Let's run this. Okay. First one went through fine. Second one. The admission office also wants to give students who have a high GPA and strong personal statement a chance even if they don't participate. If an application meets the cutoff point for the GPA and personal statement score, but not extra to... Okay. So, this is an ELIF. Okay. So, it's saying that if the GPA is 3 and the PS score is 90, but the EC count is not 3, then we should write this message. So here's a question for you, Kevin. Should we write an ELIF statement that only looks at the EC count? Or, for example, well, I guess we need to satisfy the GPA. Like, the easiest way to do this would be to copy this statement and then put this as an OR statement, right? Because the OR statement would come back false. So if this would come back true, this would come back true as well. I return this statement. So it says, if the application meets the GPA and the personal score, so if these conditions stay true, I feel like there's a way to make this smaller, right? So if the first statement fails, meaning if it fails because the EC count fails, you know what though? we have to make sure that their GPA is above 3 and that their PS score is above 90. So this and this, or EC count is greater than 3. So this could only fail if the EC count fails. So then we only need these two conditions to be true. Right? The GPA has to be greater than 3, and the PS score has to be greater than 90. And then for everything else, let's see how this goes. Let's actually delete this and let's run this and see what happens. So that's good. And then finally, we can say else. This application should be rejected. I just feel like there's a way we can shorten this, but I don't know how. And I'm sure somebody sitting watching this is going, it's so obvious. Why didn't you do it this way? And by all means, post it under the video. Tell us that there's a better way to do this. But this is what I came up with, and apparently it works. Alright, cool. So that is it. And it looks like the next thing that we'll work on, which obviously will be later in the week, is a shipping application. Let's see. So we have a project. So we're gonna build an actual application for ground shipping, drone shipping, and premium ground shipping. So that'll be fun. All right, guys. Kevin, any last? You want to review the course? What you learned today? What I learned today? What we learned today? Where'd your brain fry?
Awesome. A little bit. What do we do? We definitely went over Booleans. I don't know if that was first, right?
No, we did.
Yeah, but okay. Booleans, and then the conditional statements. If, else, if. And we covered, what is this? And or.
Yeah. So and or, which are what are they? Comparison operators or relational? They're comparison, right? And or comparison, and then relational would be the greater than equal to, because the relational needs context. So yeah, control flow in general, like how to write an if statement, right? So like after we write these functions, the functions are going to take in a parameter, and then they're going to run a condition against it. And that condition is going to be based on an if, else, if, or an else statement that says, okay, so a good example of this would be like if you had a password, right? A username and a password. You created a function. When somebody clicks a button, you create a function that triggers. And what that function does is says, okay, that person just clicked submit, so trigger this function. Have the function go look at the username and go look at the password. And if the username has the correct password, so if username is in our database, then move on to the next piece of code. If the username is in our database and it has a password, and that password matches the password that the user put in, go ahead and move that user into the next web page, right? So conditional statements are they're kind of the backbone of a lot of code. You can do a lot with them. They control the flow of your code. They determine, it's a diagram of true or false. So is the age greater than, for example, like somebody signing up for a website like Facebook or something, it says you have to be 13 or older. There's a condition that says if the user is less than 13, or the user age is less than 13, then print the message, I apologize, but you cannot join Facebook. Else, if the user is 13 or greater, then print the statement, welcome to Facebook. All right.
Yeah.
All right. So yeah, control flow. We went over a lot of control flow. Boolean. I mean, this stuff. I mean, now, like after like so many years of working on code, it just seems like super basic stuff. But there's a real appreciation for understanding how logic works, like with the not statement and stuff like that. But either way, good show. We will be working on Sal's shipping application next, and I'll send out an email to the crew. And we are. Let's see how far we are into this. We are 19% into this. Not bad, not bad at all. 1/5 of the way done, and then we can start doing the hard stuff after we get to 100%.
Awesome.
All right, man. For Cycle 35, I'm Jeff Bella. That is Kevin Williams. You guys have a good one. See you next video.